video, I'll explain subtopic 2.3, which is the chemical property of carboxylic acid. So here, let's look at some common name of the carboxylic acid. But before that, let's recall, for the carboxylic acid, the functional group is the carboxyl group, or we say it's the COOH group. So remember, this functional group, which is the carboxyl group, will determine the chemical property of carboxylic acid, which you will learn in the coming slide. So here, the general formula of carboxylic acid is Cn, H2n plus 1, COOH, whereby the n start from 0, 1, 2, or 3. So say that, for example, when n equal to 0, I had C0, H, COOH, and this is what we call it as the methanol acid. So another name for the methanol acid when n equal to 0 is known as the formic acid. And next, when n equal to 1, I have CH3COOH, and for this we name it as ethanoic acid. And another name for the ethanoic acid is the acetic acid. And then moving on, we have the methanol acid, ethanoic acid, and moving on we have propanoic acid, the butanoic acid, and also butanoic acid, pentanoic acid, and many more. So this you can refer and have a look. So this is for your knowledge. So next we will learn about the preparation of carboxylic acid. So you have learned in the previous video, the alcohol, it can undergo oxidation by using the oxidizing agent to produce ethanoic acid. So here we will prepare the carboxylic acid by the oxidation of alcohol. So for example, we have a reaction here, the ethanol, we use the ethanol undergo oxidation to produce ethanoic acid. So here, as you can see, the ethanol will undergo oxidation reaction with the oxidizing agent such as the acidified potassium manganate or the acidified potassium dichromate to produce ethanoic acid. So the method for the oxidation of ethanol is a reflux method. So why we will use reflux method is that we want to make sure the ethanol can react completely with the oxidizing agent. So like I mentioned, for the oxidizing agent, we have two different types of oxidizing agent that can be used for the oxidation of alcohol. So first of all, for the first oxidizing agent, which is the acidified potassium manganate B7 solution. So if we use this oxidizing agent in the oxidation reaction, so the observation is the purple color of the solution will change to colorless. Meanwhile, for the second oxidizing agent, which is the acidified potassium dichromate solution, so you will observe the orange color of the solution will change to green color. Next, let's look at the chemical property of carboxylic acid. So the chemical property are determined by its functional group. So in this case, for the carboxylic acid, the functional group is the carboxyl group, COOH. So carboxylic acid, it can react as an acid. So based on the word carboxylic acid, it's quite clear. You have to know it is acid. So it can react as an acid, and at the same time, it can react with the alcohol. So when carboxylic acid react with the alcohol, it will produce ester, which have a fruity smell. So you will learn more detail regarding ester in the coming video. So basically, for carboxylic acid, it's a weak acid. So what is meant by weak acid? So basically, the weak acid is the one that ionizes partially in the water, which means it will not ionize completely in water. So for example, we have the example here. This is the ethanoic acid. So when we use the weak, for example, for the ethanoic acid, which is a weak acid, so in this case, most of the acid molecule remain unchanged in the water. So that's why it will produce a very low concentration of hydrogen ion. So here, the ethanoic acid, when it dissolves in the water, the hydrogen ion produced it have a low concentration. Like as you can see here, it have a low concentration, and it is a small amount, in a little amount, it's small amount. So some example of the weak acid including ethanoic acid, the citric acid, and also phosphoric acid. So the other one other than the weak acid is a strong acid. So for the strong acid, basically it can ionize completely in water, which means it will produce a higher concentration of hydrogen ion. So like I mentioned just now, the ethanoic acid is one of the weak acids. So when you talk about acid, the acid can always react with the base. So as carboxylic acid, it can react with the base to produce carboxylate salt, and also at the same time it will produce water. So here is one of the example. We have the ethanoic acid, react with the base. In this case, is the copper 2 oxide CuO to produce the copper ethanoate and also water. So here is the equation for the reaction. And next, the carboxylic acid can also react with the metal carbonate. So whenever you see the words carbonate in the reaction, so it will always produce the carbon dioxide gas as the side product. So here we have the carboxylic acid react with the metal carbonate. Again, it will produce the carboxylate salt, the water. At the same time, it will release or produce the carbon dioxide gas. For example, again, we use the ethanoic acid react with the metal carbonate such as the sodium carbonate. It will produce sodium ethanoate, and also it will release carbon dioxide gas and also produce water. And last but not least, we have the reaction between carboxylic acid and metal. So usually the metal that we use is a reactive metal such as the magnesium. So again, in this case, it will produce the carboxylate salt and also it will release the hydrogen gas. It produces hydrogen gas. So for example, the reaction between the ethanoic acid with the magnesium metal, Mg, it will produce the magnesium ethanoate and also release hydrogen gas. So as you can see here, basically, I will just repeat what I may have mentioned before. The ethanoic acid is a weak acid. So when we talk about weak acid, it simply means the acid, it will ionize partially in the water. So here, the ethanoic acid is a weak acid that partially ionized in the water. And since it is ionized partially, it only produces a low concentration of hydrogen ion, or we say the amount of hydrogen ion produced is very small. So here, this is the equation. Ethanoic acid undergo ionization. It ionizes partially to form the ethanoic ion with a negative charge here, and also the hydrogen ion with a 1 positive charge. So here, how to construct the formula of copper 2 ethanoate. So like I mentioned just now, the ethanoic acid is ionized and form the ethanoic ion. So here we have the ethanoic ion, and by referring to the one air here, the reaction between carboxylic acid and base. So the base that we use is a copper 2 oxide, which is CuO. So the copper oxide consists of copper 2 plus ion and also the oxide ion. So here we have the copper 2 plus ion. So here the ethanoic ion, it have a charge of -1, and then for the copper 2 plus, it have a charge of +2. So by cross check the coefficient of the charge, so the 1 will go to the right, and then the 2 will go to the left. So finally, we will produce copper 2 ethanoate. So next, let's add the reaction with alcohol. So like I mentioned in the beginning of the video, the carboxylic acid can react with the alcohol to form the ester. So and then this ester, it have a fruity smell. And then in this reaction, we need to use catalyst. The catalyst that we use is a concentrated sulfuric acid. So since this reaction, the reaction between carboxylic acid and also the alcohol, it produces ester. So we call this reaction as the esterification. And of course, we have to use the catalyst, which is under the presence of concentrated sulfuric acid, H2SO4. So one example is here. So when a mixture of glacier ethanoic acid and also it react with the ethanol, and at the same time we add a few drops of the catalyst, which is the concentrated sulfuric acid, and after that we heat it, it will produce the ester that we call ethyl ethanoate. So for the naming of ester, you will learn in the coming video. So here we have ethanoic acid react with the water. So for the ethanoic acid, we have one hydroxyl group, and for the ethanol, we have one hydrogen group. So this will produce, or what we say, it will remove one water molecule, and you will get it in the product. So and then the product that you will get is the ethyl ethanoate. So you will learn the naming of ester in the coming video. So that's all. Thank you.